Objective 1. Hazard of static electricity in flour mill. Done by Saron Johnson, Kelly Wu, Jovel Thomas, and Ayana Guevara. What is static electricity? Static electricity is defined as a stationary electric charge, typically produced by friction, which causes sparks or crackling, or generally the attraction of dust or heat. Hazard of static electricity in flour mill. As flour moves down the surface of the mill, it gains charge by friction. All the flour particles will carry the same charge and therefore repel each other, causing the flour to separate into fine powder. The repulsive force pushes the particles away from each other, and air takes up the spaces in between. A static charge can ignite a spark among the particles, resulting in a dangerous explosion. For example, the flour dust explosion in East London in 1965. Objective 2. Use of lightning rods. What are lightning rods? Lightning rods or conductors are generally metal rods or metallic objects mounted on top of elevated structures such as buildings, trees, and ships. Lightning rods were originally developed by Benjamin Franklin. A lightning rod is a pointed metal rod attached to the roof of a building. The rod is usually an inch and 2 centimeters in diameter. It connects to a huge piece of copper or aluminum wire that's also an inch in diameter. The wire is connected to a conductive grid buried in the ground nearby. It is known that lightning rods provide a low resistance path to ground that can be used to conduct the enormous electrical currents when lightning strikes occur. If lightning strikes, the system attempts to carry the harmful electrical currents away from the structure and safely to ground. This system has the ability to handle the enormous electrical currents associated with the strike. How does the lightning rod work? A lightning strike consists of opposite charges of electrical energy. A negative charge or buildup occurs in the bottom part of the cloud closest to Earth, and a positive charge of energy occurs directly underneath in the ground. Separating these two opposite charges is the non-conducting dry air belt separating cloud and Earth. As the two opposite charges continue to build up and the dry air belt becomes moist, lightning starts down towards Earth in 150 feet jagged interval steps. The positive ground charge is attached upward, utilizing the lightning protection system on the building as an outlet. Use of lightning rods. To protect buildings from lightning damage, a lightning rod is used. It consists of a thick copper wire fixed to the top of a building. The part of the rod above the highest part of the building comprises of a number of pointed conductors, and the other end ends in a metal plate buried in the earth below. Another use: when a charged cloud passes by a building, a large electric field is set up between the cloud and pointed ends of the lightning conductor. This field causes air molecules to ionize, that is, the removal of air molecules from electrons, producing ions. The insulating layer in the air breaks down, making air an electricity conductor. The last use: when lightning strikes, it hits the highest point of the building. The electric current therefore flows through the spikes of the lightning rod to the earth, without causing harm to the building.